I have quite enjoyed as I've prepped it for you guys. So I hope you find it fun as well. I know that's kind of sick and twisted in my mind, but it goes kind of, we're going to shift gears a little bit and go back to some algebra. And I know some of you are very comfortable with that. So without further ado, the first thing we're going to talk about in lesson 1 is inverse variations. Now, we've talked about direct variations before. So in a direct variation, the relationship between y is always equal to the x times some constant. So whatever the x is, you simply multiply by something, and that is how you get your y. So if it's a direct variation, your equation is y equals xk. Actually, better be y equals kx, where k is your constant, and you're just multiplying by x. An inverse variation is a little bit different. Y varies inversely as x. That means k is some number such that when we divide by x, we get y. Instead of multiplying, we're going to divide by x. But that can also be written like this. If I take this equation, k over x equals y, if I multiply by x, I actually have the product of x times y equals k, which means your x's and your y's can't equal 0 because k can't be 0, okay? You can't multiply by 0 or everything is going to be 0. So x and y can't be 0, or they can't be something else. So this is an inverse relationship. So how do we tell the difference? It's pretty simple, okay? Whether we're looking at a graph or we're looking at a function or an equation, if it can be written like this, or where there's a constant times x equals the y, then it's direct. If x times y gives you the same product every time, then it's inverse. Okay, so take a look at this one. Easiest to check for inverse. 1 times 4 is 4. 2 times 8 is not 4. So right away it's not inverse. So I'm going to check direct variation. Is there a constant at x times what is 4? 1 times what is 4? 4. So 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. So this one is a direct. And I know because y equals 4 times x, because everything is just multiplied. So my k is equal to 4. All right, take a look at this one right here. My first indication is that I'm taking x times y. So if I were to, I don't know, multiply by 3 on both sides, I get x times y equals 3. You guys, that is my formula right here. So this is an inverse relationship, and I could say that k, my constant, is 3. So x and y are related such that when I multiply them together, they're always going to get me 3. Okay, take a look at the next one. 1 and 16, 2 and 8, 4 and 4. Hopefully right off the bat you say, well, when I multiply them I get 16. Multiply them I get 16. Multiply them I get 16. When that happens, that is an inverse. And my equation would be x times y equals 16. Or in other words, k equals 16. That's my constant. All right, look at this next one. Let's see, if I were to divide by 2 or multiply by 1/2, I get 1/2 x equals y, or y equals 1/2 x. And that, ladies and gentlemen, is a direct variation with my constant being 1/2. So this is direct. K equals 1/2. That's my explanation. I just like to write it as a function or as an equation, and then maybe even give my constant. Or, you know, I could say x is multiplied by 1/2 each time. Or there's a k equals 1/2 is me saying there's a constant of 1/2. All right? So let's look at this. Now, what's cool about this is we've solved direct variation before, which was kind of a pain in the butt. I think writing and solving an inverse relation is even easier, because if it's an inverse variation, then x times y gives you the same amount every time. So assume that y varies inversely as x. That means x times y is going to give me some constant. Well, then they give me if y is negative 6 when x is 3, okay, so 3 times negative 6 equals my constant. So my constant is negative 18. It says write an inverse variation that relates x to y. Well, right there, I could write this, x times y equals negative 18, or if you want to show it as a division, you know, it would be y equals negative 18 over x. Either one of those are acceptable. Either one. I like this one, just seems a little easier to me, but if we're graphing it and we need it, this one might be easier. So it's just good to be able to do both of them. Okay, so right here, let's do this example. Assume that y varies inversely to x, so then we get xy equals k. If y equals 18 when x equals 2, so 2 times 18 equals k. So what is our k? 36. So write an inverse variation. X times y equals 36. Sorry about that, a little sloppy. Or y equals 36 over x. Okay, moving on. Back to that first page of notes. We can, if we are given that they vary inversely and they give a set, then I can find a missing measurement, okay, with the product rule. Now, they show this as that, and I think this one's much easier. If y is 7 when x is 24, find y when x is 10. Well, if x times y equals a constant, then x times y of one set of ordered pairs is going to equal x times y of the other set of ordered pairs. So if y is 7 when x is 24, so that'd be 24 times 7. That's going to give me the same constant as any other pair. So when x is 10, what's y? So right here, I'm just going to multiply 27 times 4, which gives me 108. And then all I have to do is divide by 10. And I shouldn't need a calculator. It's 10.8. There you go. Next one, assume that y varies inversely as x. If y is 3 when x is 12. So 12 times 3 is going to equal x times 4. How are we going to find x? Well, 12 times 3 is 36. Divide by 4. And x is 9. It is that simple. Okay, inverse relation. All right, we can use, there are problems, real life word problems that deal with this on the very bottom of the back page. It talks about, we're going to use that product rule to write an equation and solve it. So when two people balance on a seesaw, their distances from their center are inversely proportional to their weights. If a 54-pound child sits 4 feet from the center, how far should a 36-pound child sit from the center? Well, if they're inversely related, then a 54-pound child that is 4 feet from the center is going to be the same product as a 36-pound child some distance from the center. And let's find that because the constant has to be equal. So 54 times 4 is going to be 216. And then when we divide by 36, you should get 6. 216 divided by 36. Yes. So 6 feet. That's how far the 36-pound child should be from the center. All right. Last page of notes. We have to graph inverse relations. Now, it's not a straight line, and it actually is going to be two separate numbers, and here's why. It says graph an inverse relation where y equals 8 and when x is 3. In other words, x times y equals k, so 3 times 8 equals k. So what is our k? Our k is 24. So how do we write our inverse? I'm just going to go x times y equals 24. There's our inverse relation. So we're going to choose values for x and y, and I'm actually going to do two sets of values because if it equals 24, I could have two positive numbers being multiplied together and two negative numbers. It's going to give me two different sort of pieces of the graph, all right? So let's just easy numbers, 1 and 24, right? 2 and 12. I'm going to use those numbers that give me a product of 24. 3 and 8, 4 and 6. Now I can keep going. 6 and 4, 8 and 3, 12 and 2, and 24 and 1. Now, some of these numbers are big, for example, 24 and 12. You may or may not fit them on here. This is a pretty good sized graph, so I'm going to go ahead and go by ones. But before I do that, I'm actually going to make another table over here. And the reason I'm going to make another table over here is because while I have 2 positive numbers equals 24, guess what? 2 negative numbers will also equal 24, positive 24. So I have the exact same graph, but negative numbers. So let's see what that looks like. All right, I'm not going to fit the 24 on there, and the 12 and 2 is actually just off the graph. 3 and 8, actually 2 and 12 would be up here. 3 and 8, 1, 2, 3, 4, 5, 6, 7, 8. 4 and 6, 1, 2, 3, 4, 5, 6. 6 and 4. 8 and 3. And 2 and 12. I'm not going to fit the 24 on here because I'm going to go by ones. But it's going to give me a curved line. Now, the negative ones will also give me another curved line. So, negative 2, negative 12, negative 3, negative 8, 1, 2, 3, 4, 8, 4 and 6, 6 and 4, 8 and 3, 2 and 12. And I get one that mirrors it. So an inverse function will have 2 different curves that are mirroring one another. Okay, take a look at the very bottom. Direct variation. Direct variation is a linear, so it's a line that goes through the origin because your b is 0, so it has to go through 0, 0. Y varies directly as x. The ratio is y over x. It's a constant. Okay, if it's inversely, then it's k divided by x, or x times y equals k. And the product is a constant, and it's going to look like this or like this. Okay, we're positive or negative? Positive or negative. So your assignment is going to be identifying whether or not that's direct or indirect and giving me a reason. Then it's going to be solving for missing measures, which we did. And then last but not least, actually first, is going to be graphing them. There are 6 graphs. Just choose appropriate numbers. You know, if you need to use a fraction, you can, but you shouldn't have to oftentimes. And you may have to change what your graph goes by. Talk to me about that. You might have to go by 2s or 5s. But it will be a curve that is directly across from each other, whether they're here or they might be here. Okay? If you have any questions, come and see me. And your assignment's on the back of your paper, right here, 14 through 34 all. So, and there you will need 6 graphs, so grab yourself a sheet of graph paper so that you can graph them. All right, good luck.